Today we are going to have a look at what is inside an atom. In fact, there are protons, neutrons, and electrons. We call them subatomic particles. In the past, people think that atoms are the smallest unit that is indivisible. From the word itself, the word atom comes from atomos, a Greek word meaning indivisible. John Dalton proposed an atomic theory. Atom is the smallest part of the element having the chemical properties of the element. Let's appreciate how small the atoms are. Their volume is around 10 to the power of negative 24 cm cubed, and the mass is around 10 to the power of negative 23 grams. There are different chemical symbols for elements and atoms. These chemical symbols represent the elements' names. They either come from English words, Latin words, or named after scientists. For example, aluminium has a symbol of Al. Argon has a symbol of Ar, etc. We may have a look at the periodic table to know more about how to know the symbol of the elements. Some examples of Latin-based chemical symbols include lead. The Latin for lead is plumbum, which has Pb in it. Therefore, people just call lead Pb. Keep in mind that the chemical symbols of elements are also the atomic symbols of the atoms. So without further ado, let's dive right into our topic, talking about the subatomic particles. Atoms are made up of protons, neutrons, and electrons. Protons are positively charged, neutrons are neutral, while electrons are negatively charged. Protons and neutrons is in the center of an atom. They're tiny and extremely dense. Protons and neutrons packed tightly together in the center, called the nucleus. The nucleus is positively charged because the protons are positive, while neutrons are neutral. For electrons, they are found in the empty spaces. Electrons are very light in mass. They move around the nucleus. The atomic number of an atom is actually equal to the number of protons in the atom. The mass number of an atom is equal to the number of protons plus the number of neutrons. You might be asking, what about electrons? In fact, electrons are too light that it doesn't make too much difference in terms of the mass. Therefore, the mass number of an atom is just the number of protons and the number of neutrons. All of these can be found in the nucleus. We know that the number of electrons are equal to the number of protons, as atoms alone are electrically neutral. However, we can't decide the number of neutrons directly. In fact, we may consider the following example. This shows the full atomic symbol of carbon-12. In fact, the top left-hand corner, where it is 12, that represents the mass number, which is the sum of protons and neutrons. The number 6 represents the atomic number, which is basically the number of protons. As mentioned before, the number of electrons is equal to the number of protons, as atoms alone are electrically neutral. So how can we deduce the number of neutrons it has in carbon-12 just by looking at the full atomic symbol? Let's recap. 12 represents the mass number, which is proton plus neutron. Let n be the number of neutrons, and the number of protons plus the number of neutrons will equal to the mass number. Right? That's why we can set up a formula, 6 plus n equals to 12. As a result, we can calculate the number of neutrons denoted by n is 6. Do you know what is the mass number, atomic number, number of protons, number of neutrons, and the number of electrons just by looking at the full atomic symbol? In fact, the mass number will be 4. As the mass number will always be the left-hand corner, upper left-hand corner of the full atomic symbol, the number of protons is 2. Remember, the number of protons usually can be found at the bottom right corner of the full atomic symbol. However, sometimes the number of protons can be omitted when writing the atomic symbol. That's when you have to use your own recitation or the periodic table. It is recommended that you remember the first 20 elements of the periodic table as they are very important. Remembering them will improve your speed in working out for the number of protons. So let's have a look at the number of electrons. It is equal to the number of protons again because atoms should be electrically neutral. And this is very important to remember because when you have to study ionic bond and covalent bond, you will find it useful. Now the number of electrons will be equal to the number of protons, so it will be 2. And for the number of neutrons, it will also be 2, as we can find the number of neutrons by subtracting the number of protons from the mass number. The atomic number is equal to the number of protons, which is equal to 2. Now it's your turn to practice. Let's see. In this atom, can you identify the number of protons, the number of neutrons, and the number of electrons? Pause the video if you need more time. The number of protons will be 11. The number of electrons will be equal to the number of protons, which is equal to 11. And the number of neutrons will be 23 minus 11, which is basically 12. So in this sodium atom, the number of neutrons is 12. If you need extra practice, you may download and print out the worksheet, which is linked in the description below. So after all the exhaustive practice that we've done in calculating the number of neutrons, you might be asking, so an atom could have different numbers of neutrons? The answer is yes. However, before we talk about isotopes, let's recap on the basic things about atoms first. When we have a look at the periodic table, there's a number that is at the top left-hand corner of each element, and that word is the atomic number. For example, in lithium, the red one, which is 3, is actually the atomic number. And atomic number is actually basically the number of protons an atom has. If the number of protons changed, that will no longer be the same element. For example, let's have a look at carbon. If the number of protons increased from 6 to 7, it will no longer be carbon. Bye-bye carbon. It will be another element, nitrogen, which has 7 protons. And the number of protons actually defines what the element is. So, what are isotopes? Sometimes the number of neutrons are not the same, even though it's the same element. For example, carbon has different isotopes like carbon-12, carbon-13, and carbon-14, etc. So however, these carbon isotopes must have the same number of protons, which is 6, because if it isn't 6, it will no longer be a carbon isotope. It will be a nitrogen atom. So for carbon-12, in fact, 12 is the mass number. The number of neutrons will therefore be 12 minus 6, which is 6. For carbon-13, the number of neutrons will be 13 minus the number of protons, that is 13 minus 6, which gives us 7. There are actually different examples of isotopes. For all the isotopes, you will notice the atomic number, the number of protons, and the number of electrons won't change. However, the mass number will change as the number of neutrons changed. The abundance varies significantly. So, why do we have to study isotopes? In fact, isotopes have helped scientists in our daily life significantly. For example, uranium-235 can be used to generate electricity. Cobalt-60 can be used to kill microorganisms and pests in fruits, which benefits the preservation of food. Cobalt-60, iodine-125, and iodine-131 can be used to damage cancer cells with radiation. So we already know the arrangement of electrons in the atoms. They all follow a rule. In fact, there's a formula to find the maximum number of electrons. Shells. Well, Danish scientist Niels Bohr suggested the electrons orbits around the nucleus, which are the electron shells. The formula is 2n to the power of 2, where n is the shell number. For example, the number of electrons in the first shell will be 2 times 1 to the power 2, which is 2. The maximum number of electrons in the second shell will be 2 times 2 to the power 2, which is 8. And the maximum number of electrons in the third shell will be 2 times 3 to the power 2, which is 18. And the fourth shell will be 32, and so on. This might seem complicated, so let's have a look at magnesium as an example. The number of electrons will be equal to the number of protons, which is 12. So let's get 12 electrons here. Now we're going to assign these electrons to different electron shells. So for the first electron, it will get into the first cell, and so as the second one. However, when the third electron wants to get into the first shell, unfortunately, the first shell is already full. What we have to do is to place that electron into the second shell. Here comes the electrons. We have to continue the process until the second shell is full, which is 8. When it's full, we still need to place the remaining 2 electrons into the third shell, which has a capacity of 18 electrons. That is the same case for sodium, but this time let's use sodium as an example to tell you how to draw an electron diagram. You first put the atomic symbol in the middle, then we draw the electron shells represented by circles, then we draw the electrons as either dots or crosses. In this case, we'll use dots, so let's do like this. So let's draw some dots there. Later on, put the electron pairs on the sides, top and bottom of the second shell as shown in the figure. You should note that potassium, although its number of electrons is 19, the electronic arrangement is 2881 instead of 289. That's the same case with calcium. It has an electron number of 20, but the electronic arrangement is 2882 instead of 2810. But why? Isn't the third shell's maximum electron capacity 18? This is really a good question, and the simple answer is that the outermost shell must not be greater than 8. However, this is too complicated to be discussed about. We will not study this in this level of study. So let's review. An atom consists of different subatomic particles including protons, neutrons, and electrons. Number of protons is equal to the number of electrons, and the number of neutrons is equal to the atomic mass. Number minus number of protons. There are different isotopes with different purposes. Let's have a look at the revision exercise. If you need more time, just pause the video. Here's the answer. Let's have a look at questions 5 to 8. Here comes the answers. Other future videos include metals versus non-metals and relatively atomic mass and relative isotopic mass. We will discuss these all later on. Thanks for Judd Admin and Free Photos who provides images for page 3 and page 4 in this PowerPoint. Make sure to subscribe. If you would like extra practice and notes, please download the worksheets from the description below. Thank you.